Good afternoon, gentlemen and ungentlemen. Welcome to, what is it, Tandy the 13th now, I think? Yes, Tandy the 13th, and this should be the last Tandy 1000 HX video for a little bit, and then we'll get back to the TRS-80 Model 4, but in this video I'm going to reassemble the nicest parts into one nice machine, and then I won't record reassembling the leftover parts into a not as nice machine. But you saw me take the whole thing apart, so I'm sure you don't want to watch me put it back together. So I've been taking the liberty of cleaning up all of the plastic good with Windex and stuff, and just making everything spick and span here as I reassemble things. And I ran across something interesting. Now, this is the bottom part of the case that the low serial number motherboard came out of. I believe it's somewhere in the 7,000 range serial number. And over here is where the volume control goes. You have the volume control. There's a variable resistor on the motherboard, and there's a knob that comes up through this hole right here, and the volume control is completely exposed on the bottom of the machine here. And this is, I'm going to get filth all over my nice clean bottom case. Hang on a second. I was planning on using the bottom of the low serial number case because it's still got all of the rubber feet on the bottom. This is the bottom of the case that the higher serial number board came out of. I don't remember what it was, somewhere up in the 100,000, I think. I can't recall. Anyway, it's got a different setup over here. As you can see, there's no hole for the volume control to come up through there. It just the edge of the volume control is exposed through this slot here in the side, and you don't have to take apart. You don't have to take the knob out of that variable resistor to get the motherboard back in a case like this. And personally, I think this is a little bit superior design, because then you can't lose the knob off the bottom because it's captive inside of the case here. But I don't have any rubber feet for this thing, so I don't know. I'm gonna think about this a little as I continue, and I may just end up using this case anyway, just to keep that knob safe. I don't know. So yeah, this must be a later style of case. I'd be curious to know if that earlier style of case with the hole in it here is the same as what's used in the Tandy 1000 EX, and maybe they had some of those left over that they used for the HX until the tooling wore out or something, and then they made a different mold and did this improvement over here. Interesting discovery, or maybe all of you already knew that and I'm just discovering like a dummy. Okay, so I did end up using the bottom half of the case without the feet. It's got a couple of little dings here in the corners, but it's the bottom part. You can't really see it, and I think that'll be safer for the volume control anyway. Now, this is the dead power supply, and this is the one that works, and you can see that the switch on the dead power supply is in way better shape than the one on the working power supply. So maybe, I mean, the ink's starting to rub off of that one. And it is a little bit on this one too, but it's not terrible. But anyway, this is probably really anally retentive of me, but I'm going to take the nicer switch out of the broken power supply and put it into this working one. So I won't record that though. It's just a matter of desoldering shit and resoldering shit. So alright, so we're cleaned up and reassembled as far as we can go before we install this stuff. So there are two things we want to do here. We want to install this clock calendar module, and we want to upgrade the CPU from an 8088 to a NEC V20. In the previous video, I talked about how it might be easier and cheaper to interface to the 8088 versus the 8086 because of the way that it shares well, what I said was because of the way that the 8086 shares address and data lines. It has to do these like partial bus cycles and like latch the data onto the bus and then latch the address onto the bus, or maybe it's the other order. I don't know. But in any case, that requires some glue logic on the motherboard. It can probably just be done in a GAL or something. It might be done in one of these magic chips here somewhere on this board. I don't know, but I'd surmised that maybe the 8088 didn't work that way, but since it had an 8-bit external data bus, whereas the 8086 has a 16-bit external data bus. I was actually partially right and partially wrong. The 8088 does have only an 8-bit external data bus, but you still have to latch those 8 bits onto the external bus. But since you're only having to latch 8 instead of 16 of those bits, the glue logic to make it work is still probably smaller and cheaper and simpler. So maybe that's why the 8088 was used in these so-called lower-end machines, although this is much better than an XT of the time, instead of the 8086. Now the V20 is an interesting processor. The V20 and the V30 are essentially the same processor, just one of them is pin compatible with the 8088, that is the V20, and the V30 is pin compatible with the 8086. And what you get when you replace one of these CPUs with a V20 or a V30 is a little bit faster execution time, because I guess the CPU is a little more efficient. It's not much though, it's maybe like 10%. That's not enough to really be worthwhile, but what you do get is a full 186 instruction set, which is nice for running certain TSR drivers. In particular, I think that the PLIP driver has 186 opcodes in it, so it won't run. This is just what I've read. I've never actually tried to run it on something that doesn't have a V20 or V30 in it, so I may be full of shit here. But I don't think it will run unless you upgrade the CPU on these 8088 or 8086 machines. And since these, especially these Tandy 1000HXs, have such weird expansion ports, there aren't any network cards available for them. So if you want to, get connected to an NFS server and make it a little easier to transfer files back and forth to an internal disk drive, parallel IP is kind of, a convenient way to go on these. Not convenient, less of a pain in the ass. How about that? We'll have to make a special cable to do that, but that's all right. We'll do that in a later video. In any case, let's install. Another interesting thing about the V20 and the V30, I almost forgot to mention. This feature is probably never used anywhere, but they also have a Z80 compatible mode. So you could probably use that to run like native Z80 CPM on a machine like this. However, you'd have to get a CPM BIOS into the memory map somewhere. So you'd probably have to have like a bootloader that did that, or you'd have to boot DOS and then load the CPM BIOS and then run something to throw the thing into Z80 mode and start CPM. I don't know. I've never tried to do any of that and never even read anything about it, other than these CPUs do have a Z80 compatible mode, which is very bizarre. But anyway, yeah, that's the skinny with the V20 and the V30. So let's try to very carefully remove the old CPU, which is kind of hard to do. I probably should have done this before I reinstalled the motherboard, huh? Well, too late now. I'll just have to do this the hard way. Probably blocking the camera now. I'm sure you appreciate that, don't you? Alrighty. I believe I'm going to get her out without bending any pins. Let's see. Yep, that looks pretty good to me. and then we'll just install our V20 in its place. We have to make sure that the notch is lined up right, and that the pins are straight enough to go into the socket. I mean, not splayed out like they are sometimes on new chips, but surely this isn't a new chip. I got it off of eBay. Yeah, I can see where it's been in a socket before, but the legs were still kind of splayed out. I don't know. Anyway, let's, yeah, they're still kind of splayed out. I don't know how that thing was socketed before. Alright, now let's try it. Get that thing in that socket. Still doesn't want to go. Bend them a little more. You can't see on the camera, but I'm just laying the chip against the table and bending the pins over that way. Alright. I think it's gone now. You're gonna have to see my ugly face while I make sure that I haven't missed any of the pins in the back here. I sincerely apologize for that. If you have a weak stomach, or don't handle horror movies very well, you may want to look away from the camera when I stick my head in here. Kind of a shame. I was hoping you all would just think I was like a disembodied voice and hands, but oh well. Now let's see here. Yep, I believe they're all in there. Yippee skippy. In you go, my friend. Very nice. Very nice. And then we want to install this clock calendar card, and to do that we have to pull this ROM out. That is the right ROM, and plug it into the socket, and then put the whole thing, plug it into the socket on this thing, and then plug the whole thing down with the ROM socket there. Ooh, that boy's a little in there, a little better than the CPU was, but he's coming. We just have to be careful we don't bend any of his pins, because that's never good. Come on, bub, you can come out of there. Alright, very nice. Yeah. Yep, looks good. Alright, let's plug him down into this socket on this clock calendar module. There it goes. There it goes. Alright, get down in there, Bubbo. Alright, and then this thing just slots down into the ROM socket, and yeah, it's pointing the right direction. Well, that's kind of hard to see. I believe everything's lined up appropriately. Yeah, I think we're good. Down you go. Into the socket. I think it went right, didn't it? Whoop! Come hither, foam. Yeah, it's in there. Okay. Now, the thing about these clock modules is they don't automatically set the system date and time. You have to use a special program to set the time on them, and then another special program in like your auto-exec file to set the actual like non-battery backed system clock on the board from the clock module. So it doesn't magically work without any software support, but it does work with software support. So that's much better than having the wrong date all the time. Alright, well, we're ready to put the top shell back on it. You can see I didn't reinstall that RF shield. It won't fit on there with this clock calendar module in there anyway. I didn't want to cut on it or anything. But in the previous video we had an interesting discussion down in the comments section about whether or not it was a good idea to throw out those RF shields. Now, I'm still of the opinion that like electric motors and unshielded switching power supplies and shit like that are way worse radio polluters than like 8 megahertz XT class machines, like the motherboard. I mean, you know what I'm saying? So like European computers don't have all of the RF shields in them that US computers do, and I mean, if it were a real problem, I would have thought that they would have legislated more shielding in Europe as well. It seems to me like many things, those 1980s era RF shielding regulations were just yet more government over-regulation and served no real practical purpose. Maybe I'm full of shit, I don't know. If you want to try to change my mind, please feel free. I don't mean to be a dick about it or anything, that's just my opinion. Alright, all cleaned up and mostly reassembled. And it's time for expansion cards. So, first goes the memory expansion card. Get in there, you. Alright. And then the serial card, we'll put it down here. And then I have to go dig through my box of ISA cards. Hang on a second. There are several cards that I'd like to have in this thing. It'd be nice to have a 8-bit ISA network card. It would be nice to have this AdLib compatible card in here. It'd be nice to have this XTIDE card in here. I've got this adapter. It'll plug down in this slot right there, this space right here, and we can put a card in here. But the XTIDE card is too wide. It won't fit in there. So we can't do that. I do have this Monotech mini XTCF card. It's like an 8-bit XTIDE card that only supports compact flash. So it'll fit in there just fine. But if you wanted to put a bunch of actual ISA cards in these things, so the plus bus is basically the ISA bus. We'll talk a little bit more about that in a second. It's not exactly, but it's very close to being the ISA bus. So much that you can use these adapters to put 8-bit ISA cards into these contraptions. And one thing that you could do, see these plastic shrouds will just pull off of here. You could just plug a 40-pin ribbon cable into there and route it out the back into one of these contraptions. I can't remember where I got this from. It's a public domain design that you can have manufactured in groups of 3 and mailed to you. You have to solder on your own pin header, but then you could plug your ribbon cable into this. I mean, this is made for like a 16-bit ISA bus, but it'll work alright like this. And then you could plug this down into one of these passive backplanes and have as many ISA cards as you wanted. You can get bigger backplanes, etc. ad nauseum. That's kind of ugly though, without a card cage, and it sits in the back and gets in the way and all that stuff. But that's an option if you want to expand the shit out of your Tandy 1000 HX or EX. But either A, can't find plus cards, or B, don't have enough space to install all the stuff you want. Yeah, I'm just going to go ahead and use this CF adapter because it'll fit in here real nice and everything will be heavy. So, yeah. When I say that the plus bus isn't exactly the ISA bus, there are a couple of lines that are different. I don't remember all of them off the top of my head. But one of these pins gives you access to the speaker. You can send audio into that pin and it goes through the audio amplifier and the volume control and all that shit and comes out the speaker. So I think it would be really cool to design an AdLib card for the plus bus that just plugs in there and just magically gives you AdLib audio on the internal speaker. That's a project that I want to get into someday. And Professor Pterodactyl, if you are watching this, you are the Tandy 1000 EX and HX man. He has made his own like super expansion cards for these things that basically takes the place of all of this crap that I'm stuffing in here. I'm going to try to make one of those for myself one of these days that combines a CF IDE adapter along with an ad-lib card and a serial port and a RAM expansion that just, you take out all the cards, you plug it in here, and it just works. It of course wouldn't have a DMA controller on it because that gets complicated. But that's alright, we don't really need a DMA controller in this class of machine anyway. Now, you may be thinking to yourself, if you've messed with other PC and XT class machines, well shit, without a DMA controller, how does it handle the frickin' RAM refresh? I mean, these things use DRAM, static RAM was, that amount of static RAM was very expensive when these things were manufactured. So yeah, they use dynamic RAM, but the base 256K on the motherboard is actually refreshed by the video circuit. They steal some system RAM for video memory instead of having their own separate video memory on the card somewhere. So that's kind of unfortunate in a way because it reduces your executable program area a little bit. But you know, that's alright, I guess. But then when the expansion RAM goes in there on this RAM expansion card to expand it to 640K, that RAM doesn't get refreshed by the video controller chip. So it has to have that DMA controller to refresh the RAM. What interrupt does a DMA? There's an interrupt that gets generated on a timer that pings the DMA controller and tells it to do a memory refresh. I can't remember which interrupt it is because I'm dumber than shit. But that's how the dynamic RAM refresh works in general on old PCs like that. Now, all these modern expansion cards, RAM expansion cards like Professor Pterodactyl, aka Eudomorphian, I hope I'm pronouncing that right, have made, they all use like 1 megabyte static RAMs, which are relatively inexpensive nowadays, but back then they were very expensive. But yeah, the static RAM doesn't require a refresh. The circuit's really simple. You can make the circuit very small, so it wouldn't be too difficult, I don't think, to combine that and this all into a stack of 1 or 2 cards, along with a serial port that just plugged into that plus header and gave you all of the happy times for your Tandy 1000 EX or HX. So yeah, I'm going to try to make one of those someday, but probably not during Septandy because that will be an ongoing project. And you know how my projects turn out. Many projects, not enough time. Despite the bottom halves coming out of different molds, you seem to be able to swap the top halves with them however you want. This is actually the top half off of the other machine because it had a much less worn logo on it. So I went to make sure that the plus bus faced the same way as the ISA bus. I wasn't sure whether this card needed to go in with the rear of the PC actually towards the rear or towards the front. For some reason I was thinking that the plus bus was like backwards from ISA, but it appears not. So yeah, final card going in, and yeah, I already put the screws and stuff in, so sorry about that. You missed a little bit, but I'm not going to take those back out and redo it. So there she goes. The cover, oh, there's some dirt on it. We can't have that. Dirt. I'm gonna have to replenish my supply of worn out socks pretty soon because these are getting too filthy to clean stuff with. And then the CF card I already configured too, but you missed that. But you know, no big deal. I was just set up the software for the clock calendar card and had put a mouse driver in auto-exec, formatted the CF card after booting off of a floppy, all of the regular shit that you would do setting up a hard drive in an old machine like this. So then we've got the rodent. This rodent actually came with the the other Tandy 1000 HX, and it's actually quite a nice rodent. It's very hefty and good, and of course we have to use an adapter because Tandy. And then, I mean, that's pretty slick, right? I mean, I wonder if it'll run Windows 10. Yeah. All right, gentlemen. Let's see how things go. Lovely. One thing is, on this 256 megabyte CF card, it takes DOS a long time to calculate free space the first time that you type dir, so I have it doing it here in AutoExec so that it doesn't frustrate me later when it's time to actually type dir. So Tandy 16 color graphics with a Tandy speaker and a mouse. Ah, Tandy sound. That actually doesn't sound terrible. Maybe Tandy Sounds does have some kind of envelope control. I thought it was just a 3-voice square wave, but maybe I'm full of poo. Alright, that's enough of that. Let's see what else we can find. I've got a TSR installed that changes the DRAM refresh rate, speeds the computer up a little bit, but for some that's it loaded right there. But for some reason, it makes me have to hit Control-Alt-Delete twice to reboot the machine. I'm not sure what the deal with that is. So let's fire up Space Quest 3. It actually looks very good for a 16 color program. It's dithered, but I mean that looks pretty respectable for 16 color graphics, I have to say. I mean, right? There are a couple of oddities about the Tandy 1000 that we ought to look at. Huh, check it doesn't support a mouse. Didn't realize that. Okay, here we are. Alright, now look here between the red and the brown. I don't know if it's this monitor or if, well, it's got to be the monitor. Something about this CM5 monitor doesn't render the brown color right, it just looks red. This monitor does have some issues. Yeah, see, so I'm going to have to do some fixing on this monitor, but the lack of brown rendering may have something to do with whatever's loose in there that causes the blue to appear in the background like that. Not sure what the deal is, but on any other CGA monitor, the brown color ought to render right. I don't know what's going on here. The light red isn't very much lighter than the regular red either. I don't know. It's kind of strange. Also, let's look at the memory map. This monitor is also very dim. I have both the brightness and the contrast turned all the way up. I don't know if maybe the high voltage is low or if the phosphors are worn out. Now we can see the memory map here. And what Tandy Graphics do is they take a little piece of that base 256K and they map it up into upper memory for video RAM. So you actually lose 32K of conventional memory just for the video RAM. Might be, no, I'm pretty sure it's 32K, not 64K. Yeah, it's got to be 32K. We've got a big block of nothing up here in upper memory, along with that little piece down there in conventional memory. There's our 16K of video RAM that's been remapped from down below somewhere, although the memory management unit of the thing moves it all down, so all the conventional memory's in a contiguous block, even though the actual physical memory gets pulled out of the first 256K. I don't know if it comes out off the beginning or off the end. I guess it doesn't really matter. We've got 16K of UMBs here available for loading device drivers. Why that doesn't get mapped down here in conventional memory somewhere, I don't know. And then we've got another big space here. Okay, and now here's where all the upper memory goes. You can install a RAM expansion. I mean, you can put a megabyte on an 8088 or an 8086, and that just gives you a bunch of space up here in the 384 upper memory segment to load device drivers and shit like that, which is good if you're doing networking and stuff on these things. But these Tandy 1000s, they've got so much crap in ROM up here that even if you do install some kind of memory expansion in these things, you don't really get very much upper memory. So there's some kind of adapter ROM, that D000, that's probably the XT IDE option ROM on that CF card interface. So that's not actually something to do with Tandy. We've got an empty block, and then all the Tandy ROMs are up here at the end. So we've got an unknown ROM. That's probably the DeskMate ROM. It's a great big old frickin' 64K ROM. And then there's another 64K ROM up above that that's actually split into two pieces here. That's probably that ROM disk, that 8K there, and then this is probably, I don't know, maybe this might be the option ROM for that ROM disk, and that might be the actual contents of the ROM disk. I'm not sure, but Eudomorphian, if I'm pronouncing that right, I'll call him Professor Pterodactyl. That's much easier for my stupid brain to deal with. He has figured out some way to disable all of these ROMs and get more upper memory. So whenever if we ever get around to building our own Tandy 1000 HX Super Expansion card, that's definitely something that we want to look into doing. I guess that's all for the Tandy 1000 HX for now. Someday maybe we'll work on the monitor and work on all the expansion cards, but for now, I'm pretty happy. This is one of my very favorite machines. My best friend in junior high school had one of these, and I used to go up to his house and stay all weekend. And when we got tired of playing tabletop D&D, we would get on his Tandy 1000 HX and play all of those old SSI AD&D games, and that was great fun. So, yeah, I'm gonna be going to Good Old Games and buying some SSI collections and copying them onto this CF card. I think I'll start with Hills Farm. Here's some, oh wow, my fingernails are filthy. Well, I was working on the hay mower a little bit this morning. I guess I didn't get my hands cleaned up enough. Sorry, and you'll just have to deal with my dirty fingernails. I have finally, I paid too much for it, probably a third more than it was actually worth, but I finally, assuming it doesn't get mangled in shipping, fingers crossed, I think I finally have a decent working TRS-80 Model 2 with a keyboard that probably doesn't work and I'll need all the foam rebuilt in, but it's mine if it survives shipping, and that project is going to be great. I don't think it's going to get here until the 18th. There may not be time for it in September, but it's going to be awesome. I've been wanting to do this for years, okay? So I'm going to get them, well, originally I wanted to do this with a Model 16, but I think it would actually be more interesting to do it with a Model 2. Because you can take a Model 2, alright, you can put in the Model 16 or Model 6000 Motorola 68K CPU cards and RAM cards, and they all use the same hard drive controllers. Hopefully I can find some kind of hard drive emulation for it. But at any rate, I want to build like a 4 megabyte static RAM card, and I'll probably have to buy the 68K CPU card because that's a little too complicated for my dumb ass. And, no, pardon me, my supper's coming back. Burp. But then, if I can find some kind of workable hard drive emulation solution for it, because I mean, TRS-80 Model 2 hard drives cost like $500. It's ridiculous. I want to install Xenix 3 on it, and it's going to be awesome to be running Xenix 3 on it. It's going to be awesome to try to build hardware for it. Like, ideally, the end goal, I think, of that project will be to design a PC board that people can buy and then get the parts for and populate. Just one TRS-80 Model 2 card that you put into a Model 2 that turns it into a Model 6000. Because there aren't a whole lot of Model 2s around anymore, it seems like, but there are very few Model 16s and Model 6000s. I think the last one that I bid on, I think it sold for like $800. Ridiculous. So anyway, yeah, that's going to be, oops, interaction. That's going to be freaking awesome, and I'm going to document everything, and I hope that you all enjoy that project as much as I think I'm going to, because it's going to fucking rock, man. Yeah. Alright, so I've blathered long enough. See you guys next time. Thanks for watching. Next time, TRS-80 stuff. Yeah.